So, like 4.5 billion years ago, this Mars-sized planet, they call it Theia, basically T-boned the Earth. I mean, it completely liquefied our crust and blasted enough debris into space to form the moon.
Yeah, it was a ridiculously violent start. It's wild to think about.
Right. And today we are doing a deep dive into all of this using data from NASA, space.com, Popular Science, and Wikipedia. We really want to uncover the apocalyptic aftermath of that cosmic hit and run and, well, what would happen to you if our moon just suddenly vanished?
Because that chaotic birth, it actually left some really lasting scars. Like, we tend to picture moons as perfectly uniform spheres, you know?
Oh, totally. Just like a giant cue ball or a marble in the sky.
Exactly. But because of how that debris clumped together after the impact, the moon's interior is actually incredibly lumpy. It has these massive, super dense concentrations of heavy metals just scattered totally unevenly inside it.
Okay, wait, let me unpack this. So it's almost like a weighted die. Like if you roll it, gravity grabs the heavy side and pulls it down. So Earth's gravity is basically just holding on to those dense, lumpy spots.
Yes, that weighted die metaphor is actually perfect. It perfectly explains the physics at play. Earth's gravity pulls way harder on those denser regions, and over millions of years it essentially slammed the brakes on the moon's rotation.
Oh, wow. So it just forced it to stop spinning.
Yep, it's a phenomenon called tidal locking. And it's the exact reason why we only ever see one face of it from down here.
But see, if it's permanently locked facing us like a loaded die, it sounds completely dead. But reading through these NASA reports, they're tracking actual movement. Like, how can a locked rock still be dynamic?
Well, for one thing, it's physically moving away from you right now.
Wait, moving away, really?
Yeah. So Apollo astronauts left these retroreflectors. They're basically just specialized mirrors up on the surface. And by bouncing lasers off them, scientists know for a fact the moon is drifting away at about 1.5 inches a year.
That is crazy.
And if we rewind the clock to right after that Theia collision, the moon would have just dominated the sky. It would have appeared like 16 times larger than it does today.
Okay, that is a terrifying image. Just a giant rock looming over everything. But the data shows it's not just drifting, right? Like, it's got stuff happening right on the surface.
Right. So NASA sent this probe called LADDUS, the Lunar Atmosphere and Dust Environment Explorer, specifically to sniff out the environment orbiting the moon. And what they found completely shattered the idea of it being a dead rock.
What did they find?
Well, the moon is constantly being pelted by microscopic space dust. And when those micrometeors strike the surface, the kinetic energy creates intense shockwaves that literally vaporize the soil, that releases water molecules that are trapped deep underground.
Whoa, okay, here's where it gets really interesting. You're telling me it essentially breathes out water vapor every time it takes a hit from space dust.
I mean, yeah, it is constantly venting. And it gets better. Just beneath that battered surface, there are massive, hollow lava tubes left over from its ancient volcanic past.
Like actual underground caves.
Exactly. We can actually see these skylights from orbit where the roofs of these caves have collapsed. And because they maintain a perfectly stable temperature, they are honestly the ideal, ready-made habitats for future human lunar bases.
That is amazing. But, you know, if the moon is constantly drifting away, that raises a pretty dark question. What happens when it drifts too far? Or, worse, what if a rogue planet just obliterated it tomorrow? Like, what actually happens to us?
Well, the most immediate shock to your daily life would be the oceans. Tides wouldn't stop entirely. I mean, the sun's gravity drives about 30% of our tidal movement. But the water levels would shrink by 2/3.
I mean, that doesn't sound entirely apocalyptic. Just smaller waves at the beach, maybe?
You'd think so? But if we connect this to the bigger picture, a sudden 2/3 drop in tides would completely collapse intertidal ecosystems around the globe.
Oh, right, because of the food chains.
Exactly. Those coastal zones are the foundation of massive ocean food chains. Plus, without moonlight, nocturnal predators like owls and lions would suddenly be hunting in pitch black. They'd struggle, while rodent populations would absolutely thrive.
Okay, a global rat plague. Yeah, definitely apocalyptic.
And the climate consequences are even worse. So Earth isn't a perfect sphere, right? It bulges at the equator. The moon's gravitational pull acts like an invisible anchor on that bulge.
Ah, okay.
Yeah, it prevents the gravitational tugs of the sun and Jupiter from pulling us off balance. It holds our axial tilt steady at exactly 23.4 degrees.
So what does this all mean for us? Is the moon basically just the gyroscope keeping Earth's climate from spinning out of control?
That's exactly it. Without that anchor, Earth would wobble wildly like a dying spinning top. Over time, the North and South poles could end up pointing directly at the sun while the equator completely freezes over.
Wow.
Yeah, you'd be looking at extreme, completely unpredictable ice ages.
Man. So, for you listening, the next time you look up, just remember that the moon isn't just a stage prop. It literally regulates the weather you experience and the oceans we all rely on, which actually brings up something pretty wild from the research.
Oh, about the exoplanets.
Yeah, every time astronomers look for habitable Earth-like planets out in the galaxy, they are actually looking for planets with massive moons.
Right, because of that stabilizing effect.
Exactly. It really makes you wonder, I mean, how many perfect planets are out there
Hey.
sitting right in the habitable zone, but they are completely dead simply because they never got lucky enough to get smashed into?